A very good evening, everyone. Myself, Dr. Pankaj Kharade, and today we are going to discuss about CAD CAM in prosthodontics. As we all know, CAD CAM is an acronym for Computer-Aided Designing and Computer-Assisted Manufacturing. CAD CAM assists to improve the design and creation of dental prostheses, including crowns, veneers, inlays, and onlays, fixed bridges, dental implant restorations, complete or partial dentures, and implant surgical guides. CAD CAM technology was introduced in dentistry in the year 1989 by Moorman and Brandestini in Germany, and today it is widely used in all the branches of prosthodontics. Using these CAD CAM technologies, various types of restoration and dental prostheses can not only be designed but also machined with accuracy and precision. Over the past 25 years, CAD CAM technology has become extremely popular. The introduction and evolution of CAD CAM technology in dentistry has greatly revolutionized treatment concepts and prosthesis fabrication. Although this technology has been well established in fixed prosthodontics, it is still at a developing stage in the field of removable prosthodontics. CAD CAM for complete dentures was introduced following the success of CAD CAM in implant and fixed prosthodontics. CAD CAM has emerged as a new approach for design and fabrication of complete dentures. Now, regarding advantages of CAD CAM, first of all, and the most important thing is no traditional impressions are required. As we all know that we are using these intraoral scanners for most of the cases, and that is why there is elimination of this impression procedure, and that is the basic advantage. Then next advantage is it produces the chair side restorations. Less number of appointments are needed, high precision and accuracy. It improves the quality of restoration. It eliminates the use of laboratory equipments required for lost wax technique during the casting procedures. Speed, ease of use, and better quality of digital scans, faster design and fabrication. Apart from that, there is natural appearance of CAD CAM restorations. And again, one more important benefit is it prevents the cross-contamination. Now, regarding the drawbacks, the most important drawback is the high cost which is incurred for installation of this CAD CAM system, and also for the training of the procedures which are related to this CAD CAM system. Then next drawback is wastage of material. So when we are milling from the prefabricated blocks, or we are milling from the blocks, excess material will be wasted because we are getting a very short span of prosthesis, or a very limited amount of material is used for fabrication of the prosthesis, and remaining material will be wasted. So that is again another drawback. Then next drawback is limited capacity to shape complex details like undercuts, and there might be some problems with occlusal vertical dimension. Now, there are three basic components of a CAD CAM system. The first one is scanners, in which we have these intraoral scanners and desktop scanners. Then second component is design software. It is used for designing these restorations. And the third one is digital fabrication process tool. Now, regarding intraoral scanners are devices for capturing direct optical impressions in dentistry. The intraoral scanner is a medical device consisting of handheld camera, that is hardware, a computer, and a software. The most widely used format of 3D digital file extension of images captured by intraoral scanner is STL. STL means the standard tessellation language file, and this file describes the surface geometry of an object in 3 dimensions, showing attributes common to CAD 3-dimensional object models. Now, these are the intraoral scanners which we use for scanning the repaired area in the oral cavity. And while recording or while scanning the area, we have to start from one end of the arch and we have to proceed towards another end. First, we record the occlusal surfaces, followed by buccal, and lingual surfaces. Now there are different scanning technologies. The first one is triangulation. Triangulation is based on a principle that the position of a point of a triangle, the object, can be calculated knowing the positions and angles of 2 points of view. The next technique is confocal. This technology enables detection of image sharpening to infer distances in relation to the object according to the focal length of the lens. The level of sharpness obtained in this scan is directly proportional to the dexterity of the operator. The next technology is active wavefront sampling, that is AWS. The AWS technique enables the capture of a surface imaging using a camera and an aperture of the optical axis of a module that rotates around this axis. Distance and depth information can be derived and calculated from the outcome of each point. The next technique is stereophotogrammetry. It estimates all coordinates, that is x, y, and z, solely by using an image analysis algorithm. Now, regarding limitations of intraoral scanning, the first limitation is highly reflective surfaces. They are very difficult to scan, and that is why whenever we are scanning a prepared surface, we need to avoid additional lights like the light which is coming from the chair, so that there will be minimum reflection and the surface can be recorded or the surface can be scanned very precisely. The next limitation is very deep subgingival preparation. They cannot be recorded precisely. Then moisture and bleeding affects the quality of scanning. Mouth opening is very important. Whenever you come across a patient with less or restricted mouth opening, the scanning procedure gets affected and it will affect the final outcome. Then adjacent oral structure, they may interfere with the scanning, and excessive proximal height of contour, it will affect the scanning procedure. Now, regarding desktop scanner, a desktop scanner is a dental model scanner that allows dental technicians to simply place a model inside it, press a button, and the scanner generates a digital file that can be 3D printed. Now, there are three different models. The first one is mechanical scanner with probe. Second is laser scanner. And the third one is white light scanner, which is most commonly used. Now, when we compare the precision or the capacity of scanning, desktop scanners, they are considered more superior as compared to intraoral. Now, this is a desktop scanner where I'm going to show the procedure. In this procedure, as you can see, the models, they are mounted on an articulator, and the models along with articulators are being scanned, and this the scan image, it will be developed, and with the help of software, it will be seen on the monitor of the desktop. So this is how it is scanned. Apart from that, we can scan these models separately also. In this picture, you can see the model has been mounted without articulator, and it can be scanned. So for this, you need to give the suitable instructions so that the model will rotate in a 360-degree manner, so that whatever details are there, they will get recorded precisely. Now, regarding application, they are used for digital diagnostic wax-up, making single crowns, inlays, onlays, and overlays, making individual tray for total dentures, crowns, and implants, recording of maxillomandibular relationship, fabrication of occlusal plates, and surgical guides. Now, the next important thing is dental lab software. A model scanner will always come with some form of scanner software to at a minimum display the 3D file on screen and generate a dental project from it. Keep in mind when assessing software option is how well the lab scanner integrates with other parties. Now regarding the benefits of lab software, there are several benefits. The first of all, the speed of the lab software, then accuracy is very good, predictability of treatment outcome, it is cost saving, no need for physical space, the communication is very easy, one can communicate with the laboratory technician, it reduces physical errors and greater patient acceptance is there. Now this is how the software works. So first you need to select the suitable parameters for the scanning process. So as the scanning process will progress, all details will get recorded and the image will be created with the help of this software. So here you can see that the model is being scanned and the image is created. And this image will be used for designing of the restorations. Now we are going to see how these restorations will be designed with the help of this software. So the basic advantage of getting these images is you don't need the patient and basically it will act as a virtual patient for you. So now you can see the model has been scanned with the help of desktop scanner and now this software will help to design the restoration or the final prosthesis for the prepared area. Now here you can see that the margin is being designed for the prosthesis. And again, one of the important advantage of this software is that it will allow three-dimensional movement of your prosthesis. So if you want to make certain adjustment in the prosthesis, it is possible with the help of this software. So you can see that movement in any axis is possible in any plane. You can move your prosthesis and you can check for high precision outcome. So basically this adjustment will allow for a very precise outcome and you can plan your final prosthesis, and once you are satisfied then you can instruct for further process, that is printing of your prosthesis or fabrication of the final prosthesis. So here you can see that these virtual models, they will help you to assess the bite of the patient also. Now, the next part is facial scanner. The main use of face scanning is to have the patient in a virtual format without the need for the patient to be present at the time of planning. In prosthodontics, face scanning is used to determine the entire dental aesthetic analysis guided by the face, such as ideal tooth position, anatomical portions of the face, and soft tissue profile. In implant dentistry, the facials can be used to provide a prosthetically driven plan of rehabilitation for partially and totally edentulous arches. Now, there are different scanning methods which are utilized by facial scanners. They are photogrammetry, stereophotogrammetry, structured light scanning, and laser scanning. Now, in case of photogrammetry and stereophotogrammetry, this is based on capturing the images of 3D object with the help of two cameras from two different planes to generate a 3D model. Thus, it obtains the information from multiple photographs that are then stitched into a three-dimensional image. So here you can see that the image is being recorded from two different angles, and they will be stitched to form a three-dimensional image. Now the next method is structured light scanning. A structured light scanner uses trigonometric triangulation to capture the light patterns and obtain a three-dimensional shape of the surface of a subject's face. This mechanism requires a projector that projects a pattern of light blue, which is blue in color, onto the object, and a calibrated camera that captures the projection. The light is registered from various angles, and a three-dimensional mesh can be computed based on the displacement of the light pattern. Now, advantages of structured light technology includes its speed, accuracy, and reproducibility. However, this method of scanning is sensitive to lighting conditions in which additional ambient light can distort the scan. Now, next method is laser scanning. Laser scanning utilizes similar technology to light scanning by capturing the reflection of the laser from the object being scanned. A camera is able to detect the geometry of casted laser beam and compute the distance and shape of the laser in 3 dimensions. For a complete 3D facial scan, the laser scanner requires multiple consecutive scans with the subject rotated in different positions. Now, next method is facial scanning with smartphone. With the advancement of technology, face scanning can be performed in a way accessible to the professional. Acquisition can be done from smartphones, tablets, cameras, and also using photogrammetry to generate three-dimensional files. The facial scan file is usually exported in OBJ file format. No significant differences accuracy, and it is used with different apps like Bellus 3D, Face App, Face 2 Gene. Now, regarding the design software that can turn the captured images into digital model to produce and design the prostheses. Special software is provided by the manufacturers for the design of various kinds of dental restoration. The software of CAD CAM system presently available in the market is being continuously improved. The latest construction possibilities are continuously available to the user by means of updates. The data of the construction can be stored in various data formats. The basis, therefore, is often standard transformation language, that is STL data. Many manufacturers, however, use their own data formats specific to their particular manufacturer, with the result that data of construction programs are not compatible with each other. Now, digital fabrication process tools. The last phase of dental CAD CAM process involves developing a restoration from a CAD model into a physical part that undergoes processing, finishing, and polishing before being inserted into patient's mouth. The two primary methods used to fabricate these restorations may be subtractive, that is milling and grinding, and additive manufacturing, such as rapid prototyping and 3D printing. So milling or machining technology is a type of restoration fabrication that utilizes subtraction manufacturing technology from large solid blocks. Whereas additive manufacturing is defined as the process of joining materials to make objects from 3D model data, usually layer upon layer. Once the CAD design is finalized, it is segmented into multi-slice images. For each millimeter of material, there are 5 to 20 layers in which the machine lays down successive layers of liquid or powder material that are fused to create the final shape. This is followed by further refinement to remove the excess material and supporting frame. The main problem with this type of manufacturing is that it can cause differences in the final model production because of shrinkage during building, post curing, and minimal thickness of the layer. There are several techniques that can be involved in additive technology, including direct metal laser sintering, that is DMLS, stereolithography, scan, spin, and selectively photo curing, that is 3SP, polyjet, and direct light projection, that is DLP. The primary difference is related to developing the Z plane, which represents the vertical component of the restorations. Now, the virtual articulator. The virtual articulator is a technology that simulates the jaw relation in a computer-generated setting. Virtual articulators allow a complete occlusion analysis using dental models that replicate all mandibular motions in a static and dynamic scenarios. It records or reproduces exact movement paths of mandible using an electronic jaw registration system called as jaw motion analyzer. Now here we are going to see how the occlusion is adjusted virtually. As we discussed, the movement in all three planes is possible with the help of this software. So movement can be performed in any plane, and we can check all the functional as well as non-functional aspects of the occlusion. So as you have seen, we can check the protrusive contacts, and accordingly, if any modifications are needed, they can be done with the help of this software. In this particular video, the command was given for left lateral movement, and accordingly, the occlusal contacts were assessed. So this is how the occlusion is assessed virtually with the help of this software. Now, next step is combining data and the virtual patient. So for this, you need the facial scan, virtual face bow, the intraoral scanner, CBCT, via best fit analysis. The CBCT images are in a digital imaging and communications in medicine, that is DICOM format. Facial scans are sorted as object, that is OBJ files, and intraoral scans typically are STL files. The combination of these pieces of information can be complicated. Then the next step is computer-aided manufacturing. Three-dimensional printing, that is 3D printing, also called as additive manufacturing and rapid prototyping, demands profound knowledge in addition to equipment and software requirement. Additive manufacturing process build objects by adding materials one layer at a time, with each successive layer bonding with the preceding layer until the part is complete. Now, the next part is production with CAD CAM system in prosthodontics. It is divided into three different parts. The first one is chair side production or office based devices. So, in this system, basically the instructions are given and the process is fabricated in the clinic setup or office setup only. The next setup is laboratory production. So basically, under this category, the impressions are made by the clinicians and they are sent to the laboratory where the models are fabricated by the laboratory persons using these impressions. And these fabricated models, they are scanned with the help of desktop scanners. And then the restoration or the process is fabricated. And the third type is centralized fabrication of a production center. In this, there is provision of different satellite scanners, and all these satellite scanners, they are connected with a central processing unit where all the images sent by these scanners, they are processed, and the restoration or the processes, they are fabricated. Now, regarding the milling procedure, subtractive manufacture is the sum of techniques applied to achieve the desired geometry for removing material from an initial body, usually a block. Milling can be explained as the act of removing material, that is subtractive manufacture, either by rotating the material block or by rotating the cutting tool, that is end mill. Now, the materials which are used, they are basically the prefabricated blocks of lithium disilicate, hybrid ceramics, and indirect resin. They are also used for this milling purpose. Feldspathic porcelains, and apart from that, zirconia, titanium, and acrylic resins. They are acrylic resins. They are basically used for fabrication of complete dentures and partial dentures. Now, in this video, we are going to see the milling process. How does it take place? So here you can see these end mills, and so this is another video. Now, regarding various 3D printing technologies, They are having different categories. The first one is powder bed fusion. So in this, we have the selective laser melting, that is SLM, then selective laser sintering, that is SLS, and electron beam melting, that is EBM, and direct metal laser sintering, that is DMLS. Then under light curing, there are different types such as stereolithography, SLA, digital light processing, DLP, and photojet, that is PG. And the next type is fusion, fused deposition modeling. Now, regarding application of CAD CAM in removable prosthodontics. So, fabrication of complete denture, it has the potential to simplify the complete denture fabrication process and resolve the associated problems. And comparatively, it will require less appointments. When we fabricate a complete denture in a conventional manner, we need at least 5 appointments. But when we are fabricating with the help of CAD CAM, number of appointments, they will be less as compared to the conventional complete denture fabrication process. Partial denture, the framework design is drawn on the working cast and then scanned using a laboratory scanner. The framework is always fabricated by printing a photopolymeric framework, and then it is cast with chrome cobalt, or the framework can be printed directly from this chromium cobalt through direct metal laser sintering. So both techniques, they are possible with the help of this CAD CAM technique. Either we can scan the framework design, and then it can be printed with the help of photopolymeric framework material, and then the casting procedure with chrome cobalt will be taken place. Otherwise, it can be directly printed, and the material which is used for this printing, it is chrome cobalt metal. Now, regarding the advantages of complete denture fabrication by CAD CAM technique, the first one is reduced clinical time, as we discussed just now. The database, it can be reused for fabrication of a spare denture. So whenever you are scanning the intraoral area, and the same database, it can be used for fabrication of an additional denture. No polymerization shrinkage is there, as these dentures, they are milled from the prefabricated blocks, and that is why the chances of polymerization shrinkage, they are not there. And apart from that, porosities will be absent, because these are very compressed solid blocks, and we are going to mill, or we are going to fabricate the complete denture using these blocks, and that is why there is no porosity, and the aesthetic, it is better. Now again, for fabrication of complete denture, it can be fabricated in two different ways. The entire complete denture can be fabricated from a single block, and in another technique, we just have to mill the denture base, and the teeth part, or the teeth, they will be bonded into the mill portion. Now, regarding applications of CAD CAM in fixed partial denture, they are basically used for milling of these CAD CAM based machinable ceramics, and it includes the CEREC system, CLA system, Procera system, CAD based, the Lava CAD CAM system. Now the next is application of CAD CAM in implant prosthodontics. The CAD CAM allows simplified production of precise and durable implant components. The precision of fit has been proven in several laboratory equipments and has been attributed to the design of implants. Milling also facilitates component fabrication for durable and aesthetic materials. The CAD component virtually designs the third contour of the final implant component. The CAM system produces the actual implant component according to the virtual design. The implant in implant dentistry, the implant abutments and frameworks are produced by milling at a central production facility. Examples of these systems are Procera by Nobel Biocare, Etcon by Strawman, and the CAM structure by Biomet 3i, and Atlantis by Astratech. Custom CAD CAM abutments, they combine most of the advantages of stock and custom made abutments. Then CAD CAM surgical guides. The conventional surgical guides were used to control for the manual check of the deviation in the implant axis. The direct transfer of digital planning data allows fabrication of surgical guides in an external center without the need of physical transport, which reduces the logistic effort and expense of central fabrication of surgical guides. Bebetal described the fabrication of stainless steel guides for the placement of dental implants for prosthetic retention using SLM technology. It was first reported for the manufacture of custom fitting surgical guides. Now, regarding benefits of digital workflow in implant treatment planning, first of all, precision and predictability is high. Enhanced patient communication is possible. It will save the time. Better prosthetic outcomes can be seen. Data security and storage is possible, and continuous professional development will be seen with the help of this digital workflow. Now, regarding maxillofacial prosthesis, CAD CAM is widely used for fabrication of maxillofacial prosthesis, extraoral radiation devices, individual respiratory mask, and facial protection devices, etc., can be fabricated. The three-dimensional surfaces imaging is done by using CAD software. This 3D surface image aids in fabrication of resin model with lithographic technique, and then the wax pattern is made with this completed wax pattern. Once again, computer-assisted three-dimensional imaging is done. The data is entered in computer and process is milled by a computer-aided milling machine. Thus, a silicone maxillofacial prosthesis is fabricated using CAD CAM technology. Fabrication of maxillofacial prosthesis using rapid prototyping procedure. More accurate shade matching and providing precise anatomic features is possible by CAD CAM technique. Digital technology, object change or work virtually and process into solid object with RP and M technology. Now, regarding advantages, it improves technical and clinical quality, improve efficiency and efficacy, and it improves the quality of care. So here you can see with the help of intraoral scanner, this maxillofacial defect was scanned, and you can see that it has been recorded very precisely, including the defect, which is there on the left side after resection of the tumor in the maxilla. And then the mandibular jaw, it will also be scanned, and we can create this bite for further prosthesis fabrication and arrangement of teeth. Now, regarding the comparison of conventional workflow and the CAD CAM workflow for fabrication of a maxillofacial prosthesis, when we fabricate maxillofacial prosthesis in a conventional manner, first we make the impression, we fabricate the facial mollage or the mollage, whichever area is required. Then the pattern will be fabricated with the help of wax. Either it is fabricated with the help of wax, or we are using the laboratory clay for fabrication, and then further it is processed with the help of medical grade silicone, and that is how we fabricate the prosthesis. But in case of this CAD CAM technology, first we have to scan the entire area, including the defect area. Then we fabricate by direct method, where the maxillofacial prosthesis is fabricated in silicone by using the direct technology. And there is another technique, that is indirect technique, is also available by using this digital workflow, where we fabricate the mold, which is used for fabrication of prosthesis. And in this indirect technique, the mold will be fabricated by this digital workflow, and that mold will be used for processing of the silicone. Apart from that, this CAD CAM will help for precise planning of various maxillofacial defects. Now, in this case, uh, uh, we were planning for rehabilitation with implants, but before that, we had to reconstruct this defect with a free fibula graft. So you can see that there is loss of vertical dimension. So for this, we did this planning using this digital workflow, and we have planned the reconstruction using the free fibula graph. So this is how you can plan, and precisely it can be executed, and there will be minimum problem when you plan for the rehabilitation or when you execute the prosthetic rehabilitation for this kind of patient. So this is how it is helpful in the field of maxillofacial prosthetic rehabilitation. Now coming to conclusion, CAD CAM in different dental specialization has created new opportunities for providing high quality. CAD CAM aims towards eliminating traditional impression procedures by designing and manufacturing with the help of software. Dental care at the same time theoretically enhancing patient convenience by enhancing the quality of instruments and devices being used, and CAD CAM technology can be used to create precise and effective dental components that can provide high quality care. Now, regarding the different questions which can be asked on this topic, first of all, there will be some short questions such as what are the advantages and drawbacks of CAD CAM in prosthodontics, or you can be asked about describing different additive and subtractive manufacturing techniques using CAD CAM, or the question can be framed as describe different components of CAD CAM system. And apart from that, you may get a long answer question such as describe CAD CAM and mention various applications in the field of prosthodontics in detail. So thank you very much for your attention. If you have any doubts, you can ask your doubts. Thank you.